Welcome to Arth Educational Channel. Good morning, good afternoon, good evening to anyone joining. At any time we are watching the video. Okay, so this is the third video in the lecture series of mathematics in class 9. Okay, so previously in the two lectures, what all we have learned? We have learned natural numbers. We have learned about whole numbers. We have learned about whole numbers, natural numbers, integers, then rational numbers also we have learned. Rational numbers also we have learned. We have learned about irrational numbers. Then we came to know about what? Real numbers. So we learned about natural, whole numbers, integers, rational numbers, irrational numbers, real numbers. And at the last we also learned about decimal expansion of real numbers. Real numbers. Okay. So these things we have covered in 3 sections of NCERT. These numbers are there. These all topics we have covered in the 3 sessions. Okay, that are part of NCERT's first chapter. So today what we are going to learn? Today we are going to learn about operations on real numbers. This is the 4th section and the penultimate section. Okay, this is the 4th section and penultimate section of NCERT's first chapter, that is operation on real numbers. So actually what are operations? Okay, operations requires two things. Operation actually requires two things. One is operand, another is the operator. Okay, operation actually requires what? Two things, operand and operator. What is operand? The numbers the numbers on which the operation is performed, on which the operations are performed. The numbers on which the operations are performed. See, if you are doing an operation, some numbers will be involved. Okay, so the numbers that are involved in an operation is called operand. What is operator? Operator, it is actually the operation that is to be performed on the numbers. It is the symbol. Operator is the symbol which states the type of operation to be performed. Okay, operator, it is a symbol which states that the type of operation to be performed. See, plus, or you take an example, I am doing a calculation. 2 plus 4 equals to 6. So this one is this thing. These two are operand. We are performing a operation on these two numbers. Okay, 2 and 4. We are performing a operation on these two numbers. Okay, this is the operator. That is the addition operator actually. Addition operator. Understood? This is the addition operator. Got my point? The numbers on which the operations are performed. Here 2 and 4 are the numbers on which the operations are performed. Those are the operand. And the symbol which states the type of operation. See, it is the type plus shows that we have to add these two numbers. So this is it shows the type of operation that has to be performed. Okay, now these operators are of two types. Operators are of two types. What are these? One is unary, other is binary. Other is binary. Operation performed on one number. On only one number. Operation performed on only one number. Okay. Binary is operation performed on two numbers. Okay. Operators are of two types. One is unary and one is binary. See, if the operation using an operator, if the operation is performed only on one number only, like see, this thing I am writing 2 plus 4 equals to 6. So this operator is using two operands. So it is a binary operator. Okay, it requires operation performed on two numbers, or you can say operands, on two operands. Yeah, operand. Okay, numbers are operand. Operation performed on only one operand, it is unary operator. Operation performed on two operands, it is binary. 2 plus 4 equals to 6 means it is a binary operator. Okay, but if you write plus 2, see, only 2 has no meaning. You are performing the means operation of plus, adding this plus, okay, on a single number. This plus 2, it is a, this plus now is a unary, is a unary operator. Okay, this plus 2 is a unary operator. Similarly, if you write minus 2, this minus is also a unary operator. Understood? So these are the two types of operators, unary and binary operator. Okay, now we have learned that real numbers, we are going to learn about the operations on real numbers. So real numbers are part which contain which numbers? Real numbers contain rational and irrational numbers. Okay, real numbers contain rational and irrational numbers. Rational numbers have properties well defined. Okay, irrational number have their properties not so well defined. That means a real numbers equals to rational plus irrational numbers. Rational numbers, the properties that is follows, the laws that is follows, these are well defined. Like if the rational numbers, this is going to happen, you know that this law is going to be followed. But in rational numbers, some laws are followed, some laws are not followed. Okay, so we'll see that what laws are followed and what laws are not followed. Before going on to the different laws, I want to write the two definitions. Okay, I want to write two definitions. What are those two definitions? Okay, those are, see, rational numbers satisfy commutative, associative and distributive laws for addition or subtraction. Okay, they also follow identity and inverse properties. Okay, first point is rational number satisfy commutative. See, commutative is one property, associative is one property, distributive is one property only for addition and subtraction. Sorry, I have written the wrong thing. It is not subtraction. It is actually addition or multiplication. Okay, addition or multiplication. They also follow what? Identity and inverse properties. Understood? So commutative, associative, distributive, identity and inverse properties. And these commutative, associative and distributive laws are only for addition or multiplication. These are not for subtraction or division. Okay. Third is, second point, they also follow closure property. Okay. What? They also follow closure property. Okay. So we are going to discuss one by one everything. This commutative, associative, distributive, okay, identity, inverse. One before going, right? These laws are not for subtraction and division are not applicable. Actually, applicable also you write. These laws are not applicable for subtraction and division of two rational numbers. Okay. These three laws, commutative, associative and distributive laws, these are not applicable for subtraction and division. These are only applicable for addition and multiplication. That means only for addition and multiplication operations these laws are applicable. These laws will not be applicable for division and rational. And they also follow closure property. That means rational numbers follow closure property. So we will start with the first property, that is closure property. You start with what? First is closure property. Okay. It states that actually if we add, subtract, multiply or divide two rational numbers, the resultant number will also be rational. Okay. Closure property. It states that if you add, subtract, multiply or divide two rational numbers, the resultant number will also be rational. What does that mean? Sorry. What does that mean? See, I am writing, let A and B be two rational numbers. See, we are defining these properties for rational numbers. Real numbers are there. The chapter is about operation of real numbers, but inside real numbers, we are defining the properties of rational numbers. Let A and B be two rational numbers. Okay, it is saying that if you add, addition. Okay, if you add, saying that addition A plus B equals to C. Okay, A plus B equals to C. That means C is also a rational number. C is also a rational number. Example, A equals to 2, B equals to 4. So 2 plus 4 equals to 6. 6 is also a rational number. Okay. This means that sorry, A and B, these are two rational numbers. If you add the two rational numbers, the resultant number that is we are getting, that is also a rational number. Okay, then we go for subtraction. Subtraction, what does it say? It says that if you subtract two rational numbers, the resultant number is also a rational number. See, if you subtract a and b, the resultant number is d. D is also a rational number. D is also a rational number. Okay, example, a equals to 4, b equals to 2. Okay, so the 4 minus 2 equals to 2. So 2 is also a rational number. Understood? If you add two rational numbers, the resultant number is a rational number. If you subtract two rational numbers, the resultant number is also a rational number. Now multiplication. Multiplication, a into b, suppose is giving c as result. It states that e is also a rational number. E is also a rational number. Understood? The product of two rational numbers, the result of the product of two rational numbers is also a rational number. Example, a equals to 2, b equals to 4. Okay, so 2 into 4 equals to 8. 8 is also a rational number. Understood? Then comes division. Division. What does division say? A divided by b. If you divide one rational number with another, the resultant is, that is f, is also a rational number. F is also a rational number. A divided by b equals to f, so f is also a rational number. What is a example we are taking? A we are taking as 6, b we are taking as 3. Okay, so 6 divided by 3 equals to 2. 2 is also a rational number. 2 is also a rational number. We know that and we are getting it also. Okay, 2 is also a rational number. See, 6 and 3 are two rational numbers. When we divide the 6 and 3, we are getting 2. That is also a rational number. Okay, so we are seeing that if you add, subtract, multiply or divide two rational numbers, the resultant number that we are getting, that is also a rational number. That is what the closure property says. If you add, subtract, multiply, divide two rational numbers, the resultant number will also be rational. Okay, that is the closure property. Second is distributive, not distributive, commutative property. Okay, second is commutative property. In commutative property, what we are going to learn? Let me write, let a and b be two rational numbers. Let a and b be two rational. Let a and b be two rational numbers. This law states that the operation, this law states, or not operation, see better, this law states that if we add or multiply, two rational numbers, this law states that if you add or multiply two rational numbers, okay, the result remains the same. The result remains the same. This law states that if you add or multiply two rational numbers, the result remains the same even if the order of number changes. The order of the numbers changes. What does this mean? See, it is telling for about add or multiply only. Okay, two rational numbers. First is category two rational numbers. Says that if you add or multiply two rational numbers, the result remains the same even if the order of the numbers changes. Order of the numbers, not operation. Or order of the numbers. Okay. So let me write. So it states that a plus b equals to b plus a. Understood? A into b equals to b into a. That means if you add b to a, or if you add b or a to b, okay, you are going to get the same number. Similarly, if you multiply b to a, or if you multiply a to b, you are going to get the same number. But a minus b is not equals to b minus a, and a divided by b is not equals to b divided by a. Okay. Associative property, so not associative property is also there. Here we are discussing commutative property. Commutative property is applicable for only addition and multiplication, and not for subtraction and division between two rational numbers. Okay, so this distributive property is only for addition and multiplication between two rational numbers. It is not for subtraction or multiplication. Okay, we are saying that if you add a plus b, or if you are doing b plus a, these two operations will give the same result. Similarly, a into b or b into a, same result. But a minus b and b minus a, we are not going to get the same result. A divided by b divided by, we are not going to get the same result. Example we are going to get, okay, a equals to 6, b equals to 3. Understood? So for first, a plus b equals to 6 plus 3 equals to 9. Second is b plus a equals to 3 plus 6 equals to 9. So a plus b equals to b plus a. Understood? Then again, a into b equals to 6 into 3 is equal to 18. B into a equals to 3 into 6 is equal to 18. So a into b equals to b into a. Third, a minus b equals to 6 minus 3 equals to 3. B minus a equals to 3 minus 6 equals to minus 3. So a minus b not equals to b minus a. See, you are getting 9 here, so equal. 18 is equal. Addition, multiplication, both are equal. But in subtraction, where one you are getting 3, other you are getting minus 3. So both are not equal. Okay. Similarly, a divided by b equals to 6 divided by 3 equals to 2. Okay. And b divided by a equals to 3 divided by 6, that is 0.5. 1 by 2 you are getting, that is 0.5. So one you are getting 2, other is you are getting 0.5. So a divided by b is not equals to b divided by a. Understood? So this is the commutative property. Commutative property, what does it do? It states that if we add or multiply two rational numbers, the order of the numbers, if the order of the number changes, the result remains the same. Here order is changing. Here a is first, then b. Here b is first, then a. Similarly with a and b. This is commutative property. Okay. Then we go for associative property. Associative property. What does associative property tell us? See, associative property, first we need three rational numbers. Let a, b and c be three rational numbers. Let a, b and c be three rational numbers. This property states that the result remains the same if we change the order of numbers in addition or multiplication operation. See, commutative property and associative property are similar. In commutative property, only two operands are involved, only two rational numbers are required. But in distributive means associative property, three rational numbers are there. It also states that if you change the order of the numbers for addition and multiplication, the result will not change, but they will change for subtraction and multiplication. Okay, so this law states that a plus b plus c is equals to a plus b plus c. Understood? Then a into b into c is equals to a into b into c. Okay, but a minus b minus c is not equals to a minus b minus c. Understood? Then a divided by b divided by c is not equals to a divided by b divided by c. Okay, so what does this do? See here, a plus b plus c means you have read BODMAS. BODMAS you have read. First is what? Brackets, then then division, multiplication, addition, subtraction. So bracket, inside the bracket whatever part is there first. So here a plus b will be done first, then we'll add c. The result will add to c. Okay, but here what we will do? Here we will add b plus c first, then the result will be added to a. Okay, but the result will remain the same. This law is only for addition and multiplication and not for division between two rational numbers. Okay, example: a equals to 9, b equals to 6, c equals to 3, suppose. Okay, so what? A plus b plus c, this is what? 9 plus 6 plus 3. 9 plus 6 is 15. 15 plus 3 is 18, equals to 18. Similarly, a plus b plus c equals to what? 9 plus 6 plus 3. This is 9 plus 9 equals to 18. Understood? So you are getting a plus b plus c is equals to a plus b plus c. You are getting. Similarly, a into b into c is equals to how much? 9 into 6 into 3. 9 into 3 is 6. 9 into 6 is how much? 9 into 6 is 54. 54 into 3 is how much? 162. Understood? Now it is given a into b into c. A is 9 into b into c is b is 6. This is 3. Okay, so this is 9 into 18. 9 into 18 equals to 162. Understood? So same answer you are getting, a into b into c equals to a into b into c. Okay. Similarly, now subtraction? We know that for subtraction this property does not hold. We'll calculate. A is how much? A is 9, b is 6, c is 3. Okay, 9 minus 3, 3. 3 minus 3 is 0. Understood? But b minus a, sorry, not b minus a, but But A minus B minus C. What is A? A is 9. B is 6. C is 3. So this is 9 minus 3 equals to 6. Understood? So we can write A minus B minus C is not equals to, this is coming 0, this is coming 6, equals to A minus B minus C. Okay. Now division. A divided by B divided by C. So A is how much? 9 divided by 6 divided by 3. 9 by 6 is how much? 3 by 2 divided by 3. So this is 3 into 1 by 3. 3 by 2, sorry, into 1 by the divided, you know, reciprocal. So 3 is cancelled, it is 1 by 2. Similarly, you are going to write again B I am writing first. A divided by B divided by C. Okay, A is 9 divided by B is 6 divided by C is 3. 6 divided by 3 is 2. 9 divided by 2, that is 9 by 2 equals to, you are getting 9 by 2 is the answer. So you can say easily A divided by B divided by C is not equals to A divided by B divided by C. You can say that. Understood? Here you are getting 1 by 2. Here you are getting 9 by 2. Okay, so this division is also not applicable. This is associative property. Now distributive property. What is distributive? Distributive property. Distributive property, what does distributive property says? Okay, let A and B be not 2, we need 3 real numbers in distributive property. Let A, B and C be 3 rational numbers. Be 3 rational numbers. This law states that let A, B, C be 3 rational numbers. This law states that C, A into B plus C equals to A into B. See, this operator gets distributed in the operands inside the bracket. A into B, A into C plus A into C. Similarly, A into B minus C, this operator will, okay, so A into B minus A into C. Understood? This operator will get distributed. So A into B plus C gives A into B plus A into C. A into B minus C gives A into B minus A into C. Understood? Example. What is the example? Example is A equals to 9, B equals to 6, C equals to 3. Okay, so 9 into 6 plus 3 gives how much? A into B plus C equals to 9 into 6 plus 3. This is 9 into 9 equals to 81. Now A into B plus A into C. A is how much? 9. B is how much? 6 plus 9 into C is how much? 3. 9 6 how much? 54. 9 3 27. If you add them, you are going to get 81. So we know this one is true. Both are coming as equal. A into B plus A into C. Understood? Now same thing. A into B minus C I am writing. A into B minus C is 9 into 6 minus 3. How much are you going to get? 9 into 3, that is 27. Similarly, A into B minus A into C. So this is 9 into 6 minus 9 into 3. 9 into 6 is 54. 9 into 3 is 27. So it is 27. This gives A into B minus C gives A into B minus A into C. Understood? This property, distributive property, understood? So see, what all properties we have learned? Till now we have learned closure property, we have learned commutative property, associative property, distributive property. Two more properties are remaining. One is identity property, okay? One is identity property. Identity property, what it says? It says that 0 is an additive identity. 0 is an additive identity and 1 is a multiplicative 1 is a multiplicative identity. 0 is an additive identity and 1 is a multiplicative identity. What this means, that identity means if you add or multiply a real rational number, if you add or multiply a rational number with these numbers, you are going to get the same rational number. That means, you see, let A be a rational number. Okay, so A plus 0, if you do, you are going to get A only. Additive identity. Okay, if you are going to do A into 1, you are going to get A only. So this 0 and 1 means you have to find such number that if you add to a rational number, you are going to get the same rational number. Such number is 0, and you have to find such a number that if you multiply that with a rational number, you are going to get the same number. So this is multiplicative identity. Understood? Example, A equals to 2. So 2 plus 0 you know is getting 2. 2 into 1 equals to 2. So these are identity properties. You have to find such number that if you add a rational number to that number, you are going to get the same rational number. And for multiplication, you have to find such a number that if you multiply that number with the rational number, you are going to get the same rational number. So for addition, that number is 0. For multiplication, that number is 1. That is identity property. Now we are going to discuss inverse property. Okay, this one is how much? I'm going to write additive inverse of a rational number A equals to minus of A. Okay, then multiplicative inverse of a rational number A equals to 1 by. See, what does this mean? Additive inverse of a rational number and multiplicative inverse of a rational number. See, additive inverse of a rational number means if you add the rational number and the inverse number, if you add them, you are going to get 0. Okay, if you add, see how we are getting. We have learned identity. We have learned that A plus 0 equals to A. We have learned it. So what you can write? A plus A, we are going to take this side, 0 we are going to take this side. So if you are going to take A this side, how you can write? We can write it like this. A plus of minus A equals to 0. 0 will remain as same. If you change sides of 0, 0 is going to remain the same, but A's sign will change. Okay, A's sign will change. So we'll add A plus of minus A equals to 0. So this is the additive identity. A plus of minus A equals to 0. Okay, now from identity property I have learned A into 1 equals to A. Now if you take this A to here, okay, so here only 1 will remain, so it will become like this: A into 1 by A equals to 1. Understood? So this is additive inverse, multiplicative inverse. Okay, a into 1 by a equals to 1. This is multiplicative inverse. Example, 2 plus minus 2 equals to 0. 2 into 1 by 2 equals to 1. Okay, so these are the properties, that 6 type of properties that we learned. Okay, now what are the properties of rational numbers, the irrational numbers? We learned the 6 property of rational numbers. So what is the properties of irrational numbers? So I am going to write similar to rational numbers, irrational numbers also, satisfy commutative, associative, and distributive laws for addition or multiplication. Understood? Similar to rational numbers, irrational numbers satisfy commutative, associative and distributive laws for addition or multiplication. That they see commutative, associative and distributive laws, they are same for rational and irrational numbers, and irrational numbers follow these 3 laws for addition and multiplication. Okay, but they don't follow closure property. Okay, they don't follow closure property. Okay, they do not follow closure property. Like if you add to, see, if you multiply two rational numbers like root 2 into root 2, these two are rational, irrational numbers, we are going to get 2, a rational number. So closure properties they do not follow, they follow only these 3 properties: commutative, associative and distributive laws. They follow for addition and multiplication. Okay. Next, example 11. Example number 11 of the NCERT textbook. It is given, check whether 7 root 5, 7 by root 5, root 2 plus 21 and pi minus 2 are irrational or not. Okay, are irrational or not. So see, here we are in the question, 3 irrational numbers are given actually. Okay, so I'm going to write the values of these first. That is, root 5 equals to 2.236 and it will continue. Root 2 equals to 1.4142 and it will go on continuing. Pi equals to 3.1415 and it will go on continuing. Okay, so these are the values. Now if you write 7 root 5, that is actually 7 into root 5, that is equals to how much? 7 into 2.236 and it continues. So this value that we are getting, it is coming 15.652 and something. Okay, the value of this is 15.672. So this is non-terminating, non-recurring expansion, non-terminating, non-recurring expansion, hence a irrational number, hence a irrational number. Okay, hence a irrational number. See, 2.236, this is a non-terminating, non-recurring. That is the value of root 5. If you multiply that non-terminating, non-recurring expansion with 7, you are still going to get a non-terminating, non-recurring expansion. Understood? Similarly with 7 by root 5, we will make you understand the concept of rationalization. Okay, see, if I write root 5 and the value of root 5, the bottom will be a decimal and it will become very difficult to do the calculation. So what we can do, we can do rationalization. How? We can write 7 by root 5 as 7 by root 5. This is into 1. 1 can be written as root 5 by root 5. Okay, so we'll do root 5 at the bottom and root 5 at the top. So this becomes what? 7 by 5, 7 root 5 by 5. We have found the value of 7 root 5 here. Okay, this is 15.652 and so on by 5. That is coming as approximately 3.1304. Okay, so this thing is also the same irrational number because this is non-terminating. 15.652 is non-terminating in nature. So if you divide that, that is also non-terminating, non-recurring. So it is a irrational number. Similarly to what it is given, root 2. Root 2 plus 21. Root 2 value is how much? 1.4142 and so on. Plus 21 if you do, you are getting 22.4142 and so on. So this is also a non-terminating, non-recurring expansion. Okay. Similarly, pi minus 2. Pi is how much? 3.1415 and so on, minus 2. This gives 1.1415 and so on. So this is okay. So this is also a irrational number because the decimal expansion is non-terminating, non-recurring decimal expansions. Understood? Next question. Next question given is example 12. Example 12, what they have given? Add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. They are given. Okay. So easily keep these in brackets. 2 root 2 plus 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3. Open the brackets, you will get 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3. Okay, so 2 root 2 plus root 2 gives 3 root 2 and 5 root 2 minus 3 root 3 gives 2 root 3. Okay, so this is the answer. Example then, next example. Example 13. 13 number example is written as multiply 6 root 5 by 2 root 5. Okay, 6 root 5 by 2 root 6 root 5 by 2 root 5. So 6 root 5 can write as 6 into root 5. This is 2 into root 5. This gives 6 into 2 into root 5 into root 5. We know 6 into 2 is 12. 12 root 5 into root 5 is 5. This is equals to 60. Okay, this is the answer. Then example 14. Example, what is the example 14? Example 14 is divide 8 root 15 by 2 root 3. So we will discuss a property in after a few times in this chapter. Here only in this video I will discuss that there is a property like if you write root AB, if both A and B are positive real numbers, no, you can separate it to root A into root B. But both A and B should be positive real numbers. See, these are positive real numbers. So I can separate it. See, it is given divide 8 root 15 by 2 root 3. It is given. Okay, so 8 root 15 I can add 3 into 5 by 2 root 3. A, B it is written. So A is positive real number, B is also positive real number. So we can separate it 8 into root 3 into root 5 by 2 root 3. 3 root 3 cancel. This is by 4 times. So the answer is 4 root 5. Okay. So we have discussed so many things. See, here we are adding irrational numbers. Here we are multiplying two irrational numbers. Okay. But the main example is this. See, in this example, 7 is a rational number, root 5 is a irrational number. You are multiplying a rational number with an irrational number. The result is what? The result is an irrational number. Okay. Similarly, 7 is a rational number, root 5 is a irrational number. You are dividing a rational and irrational number. The result is what? Irrational. Okay. Here root 2 is a irrational number, 21 is a rational number. What you are doing? You are adding a rational and a irrational number. The result is irrational. Okay. Here you are adding, here pi is a irrational number, 2 is a rational number. You are subtracting a rational and a irrational number. You are getting an irrational number only. So the inference that I want to write, the inference that I want to write is 1. The sum or difference of a rational number and irrational. The sum and difference of a rational number and irrational number is irrational. Okay. The sum or difference of a rational number and irrational number. You have seen in the example, if you add a rational and irrational number, or if you subtract a rational and irrational number, the resultant number is also a irrational number. Second, also the product or quotient of a non-zero rational number with an irrational number is irrational. Understood? This one is stating that the product or quotient of a non-zero rational number. See, there in that example we saw, if you multiply a rational and irrational number, or if you divide a rational and irrational number, the resultant number you are going to get, that is an irrational number. Third point is, if we add, subtract, multiply or divide two irrationals, the result may be rational or irrational. Okay, if you add, subtract, multiply or divide two rational numbers, we don't know whether the resultant number will be rational or irrational. Okay, that thing is closure property that I was discussing, that closure property. Okay, that is closure property. That it does not follow closure property, does not follow closure property. Okay, does not follow closure property. That thing we discussed, that irrational numbers does not follow closure property. Okay, one more thing is that for rational numbers, we know, natural numbers. Suppose a is a natural number. Okay, so if you write root a, the value it gives b, that is a perfect real number. Positive real number. Okay, the resultant is positive real number. Okay, root a is natural number. If you write, a is natural number, root a you are going to write, it gives the value b. B is what? B is a positive real number. If you write b square equals to a, then you can write b square equals to a where b is greater than 0. B will come at greater than 0. Okay. This is true for, this is also true for positive real numbers. Positive real numbers. That means what? See, suppose C is a positive real number. Suppose C is a positive real number. Okay, then root C equals to D. So we can write D square equals to C, where D is greater than 0. Okay, the same thing that with natural numbers that we are doing, the same thing is also applicable for positive real number. Okay, positive real number. Okay. So next we know how to plot. See, root 2, root 3 and all. How to plot on a number line. How to plot on a number line. How to plot on a number line? Root 2, root 3, how to plot on a number line? Previous section we have learned. Previous video we have learned. Okay. Now, how to plot root x on a number line? How to plot root x on a number line where x is a positive real number. Understood? Okay, so we looked at how to rationalize only if a single rational number is there. Okay, if a single rational number is there, root 2, you multiply that same irrational number in the denominator, in the numerator also. Okay, so you are multiplying the same irrational number twice, so it will become whole square and you will get a rational number. Understood? But what if the question is like this? Sorry. Question is 1 by root 2 plus root 3. See, we have already read about a plus b into a minus b equals to a square minus b square. Okay, you have read about it. So, this is a plus b. A plus b is given. If I write a minus b, okay, if I multiply it with a minus b. See, if I multiply it with a minus b. This is of this form only, no? A plus b into a minus b. What you are going to get? You are going to get a square. Okay, a square is what? Root 2 square. Root 2 square. And b is what? B is root 3 square. Understood? And since this you have written, you have to write it at the numerator also, because you have to make it at 1. Make it this as 1. Instead of 1, you are going to write this. No, from where it will come? Okay. So at the numerator you are going to write this same thing. Here at the denominator also you are going to write the same thing. See, a plus b into a minus b equals to a square minus b square. Okay. At the top the curve will remain like this. This is what? Root 2 square is 2. Root 3 square is 3. This is root 2 minus root 3. Understood? And 2 minus 3 is minus 1. So the question will become like this. Root 3 minus root 2. Minus 1. If you multiply minus 1 to this, root 2 minus root 3, it will become root 3 minus root 2. This is the answer. Similarly, if here it was written root 2 minus root 3, you would have multiplied with, see, if it was written root 2 minus root 3, you would have multiplied with root 2. A minus b is there, you have to multiply with a plus b. Okay. Since you have written it here at the bottom, so same thing at the top also. Root 2 minus root 3. So root 2 minus root 3, this will again become root 2's whole square minus root 3 whole square. At the top per root 2 plus root 3. So this will become 2 minus 3, root 2 plus root 3. So this is minus root 2 plus root 3. Okay. Understood? So if a plus b is there, you have to rationalize with a minus b. If a minus b is there, you have to rationalize with a plus b. This is the whole funda of rationalization. Understood? This is the whole funda of rationalization. Understood? Now what? Now we are going to look at examples. Now only examples and exercises are left. So we'll quickly finish this. Okay, the example number 15, what you have given? It is given, simplify the following expression. Simplify the following expression. It is given. Okay, so how are you going to simplify? Where is root 5? Not root 5, sorry. It is given 5 plus root 7 into 2 plus root 5. Okay, simply multiply. Okay, multiply 5 into 2. This is 5 into 2 plus 5 into root 5 also. This is 2 into root 7. 5 into 2 into root 7, and this is root 7 into root 5. Okay, 5 into 2 is 10, you know. 5 into root 5 is 5 root 5, you can write. 2 into root 7, you can write 2 root 7. And this one is, you know, root a into root b, and a and b are both positive real numbers. So you can inside, you can write root 7 into root 5, that is root 35. This is equivalent to root 7 into 5. Understood? So this is root 35. This is the answer. Second question is 5 plus root 5 into 5 minus root 5. Okay. So here, you know, again and again I am telling you, a plus b into a minus b equals to a square minus b square. Understood? What is a plus b? This is a plus b, this is a minus b. So instead of a, it is 5 square. A square, it is 5 square. And b is root 5. So root 5 square. A is 25 square is 25, root 5 square is 5. So 25 minus 5, you are getting answer 20. Understood? Sorry. Then this is root 3 plus root 7's whole square. You have already learnt a plus b whole square equals to a square plus b square plus 2ab. See, simply instead of a, I am writing root 3. Instead of b, I am writing root 7. So in this formula, you put a square is root 3 square, b square is root 7's whole square. Okay, 2 into then root 3 into root 7. You know this property, root a into root b, root a into root b equals to, here we are writing root a into root b. So if it is different and both are positive rational numbers, we can take it inside also. So root 3 square is 3, this is root 7 square is 7, and this is 2 root 3 into 7. So 7 plus 3 is 10 plus 2 root 21. Understood? How we are getting it? 2 root 21. This is the formula. We are taking it inside. 3 into 7. This is 21. 2 root 21. 3 plus 7 is 10. Fourth question of simplification. This is root 11 minus root 7 and root 11 plus root 7. Same a minus b. This is a minus b, a plus b. So instead of a, it is root 11 whole square. Instead of b, it is root 7 whole square. This is 11 minus 7 equals to 4. Okay. Example 16. Rationalize the denominator 1 by root 2. Okay. 1 by root 2 into root 2 by root 2. I have already done it. They rationalize. If instead at the bottom a irrational number is there, you multiply to the same irrational number at the bottom, at the top also. Means at the denominator, at the numerator also. So root 2 by root 2's whole square. Okay, so this is root 2 by 2. So you can easily multiply, you know. See, 1.4142. Root 2's value is this. By 2. You can easily divide this number. So this is the rationalization part. Similarly, example 17. What it is given? Rationalize the denominator. Sorry. Rationalize the denominator 1 by 2 plus root 3. Okay. It is given, rationalize the denominator 1 by 2 plus root 3. It is a plus b form. So what you have to do? A minus b form. A plus b. So a minus b. A plus b. This is a plus b. Okay, this is a, this is plus, this is b. This is a, this is minus, this is b. Okay, at the bottom you are doing it, same thing at the top, 2 minus root 3. Okay, now we know a plus b into a minus b sorry, a square minus b square. This is a plus b into this is a minus b. This is a square minus b square. Instead of a what? We are writing 2. So 2's square. 2's square. Instead of b we are writing root 3. So root 3 is square. Understood? At the top this is 1 into 2 minus root 3. So this is 2 minus root 3 only. Okay. So this is what? 2 minus root 3 as it is we are getting. 2 square is 4. Root 3 square is 3. So this is 1. So nothing will impact. So this is 2 minus root 3 is the answer. By 1 you can also write. Okay. So this is rationalization. Again example. Second the 18th number example. Given is rationalize the denominator. Okay. 5 by root 3 minus root 5. Understood? Same thing again. 5 by root 3 minus root 5. Understood? 5 by root 3 minus root 5. So this is a, this is minus, this is b. Okay. So what? You have to multiply it with a plus b. This is root 3. A plus root b. This is a. This is plus. This is b. Okay. Already we know a minus b into a plus b equals to that. Since we have written this at the bottom, we have to multiply it at the numerator also. Okay. So we multiplied. Now what you can write? This is 5 by a minus b into a plus b what? A square minus b square. Instead of a what you are going to write? Root 3 square, and instead of b are going to write root 5 square. Okay. Into you can write root 3 plus root 5. Understood? Now 5 by root 3 square is 3. Root 5 square is 5 into root 3 plus root 5. So this is minus of, this is 2 minus 2. So this will become 5 by 2 root 3 plus root 5. Understood? 5 by minus 5 by 2 equals to root 3 plus root 5. This is one. Example 19. Example 19. Understood how you are getting the value? Similar, same rationalization concept. Rationalize the denominator. Rationalize the denominator 1 by 7 plus 3 root 2. Okay. Sorry. 7 plus 3 root 2. A plus b is there. A plus b. You have to multiply it with a minus b. So a is 7 minus b is 3 root 2. You have multiplied. Since you have multiplied at the denominator, you have to multiply at the numerator also. This is a, this is minus, this is b. You are multiplying a plus b into a minus b. The numerator part 1 into this. This is as it is 3, 7 minus 3 root 2. Sorry. A plus b into a minus b is a square minus b square. Instead of a we are writing 7. So 7 square. Instead of b we are writing 3 root 2. So 3 root 2 square. Okay. So this is 7 minus 3 root 2. 7 square is 49. 3 root 2. See, 3 in root 2 is 3 into root 2. That means, see, 3 root 2 is 3 into root 2. Okay, so 3 root 2 square is 3 into root 2 square. So this you can write as 3 square into root 2 square also. 3 square is what? 9. Root 2 square is what? 2. 9 to 2 is 18. Okay, so how I am directly writing here 18. See, this is the calculation. You have, if 3 root 2 is given, no, you square the 3 part also, you square the root 2 part differently. Like 3 square is 9, root 2 square is 2, so 9 into 2 is 18. Okay, so that gives the answer 7 minus 3 root 2. If you minus it, it is 31. Okay, so this is the answer of the rationalization. Okay, sorry. Now we move to the exercise. Exercise number 1 by 4. Okay. First question, what it is given? First question it is given as classify the following numbers. Classify the following numbers as rational or irrational. Classify the following numbers as rational or irrational. First is 2 minus root 5. See, we know the value of root 5. I have told you the value of root 5. Okay, root 5, the decimal expansion is 2.236 and so on. I have told you. It can be root 7. I have never told you the value of root 7 and you do not have time. This, if it will come, no, it will come for 1 mark. And you do not have the time in the exam to find the value of root 7 and do the question. So you should know the property. See, either we can write, see, root 5 equals to this much, 2.236 something. So 2 minus root 5 is 2 minus 2.236 something. Okay, so it will become minus 0.236 and so on. See, root 5 was a non-terminating, non-recurring decimal expansion, hence a real number. Understood? See, root 5 is this. We are means subtracting 2 from it. So we are getting this decimal expansion that is also non-terminating and non-recurring. This is one method. But what? You should know the value of root 5. Okay. So one thing what you can do is, you know the property. I have already written here, see. Inference. The sum or difference of a rational and irrational number is irrational. The product or quotient of a non-zero rational number and a irrational number is irrational. I have already wrote about it. Okay. So you can write the same thing. You can write it. 2 minus root 5 is the subtraction of a irrational number root 5 from a rational number 2, and we know the resultant number of such an operation between a rational and irrational, between a rational and irrational number is a irrational number. See, 2 minus root 5 we are doing. We know that the subtraction or addition of a rational and a irrational number. 2 is a rational number, root 5 is a irrational number. The subtraction and as a addition of a rational and a irrational number will give a irrational number. Okay, we know that. So you can write this property directly. Okay. Second question is 3 plus root 23 minus root 23. Okay. On simplification, we get the value as 3, which is a rational number. Okay, see, 3 plus root 3 minus 23, these will get cancelled. Sorry. So only 3 is remaining. So 3 is a rational number. Understood? Third question is similar. 2 root 7 by 7 root 7. Okay. 2 root 7 by 7 root 7. Here also, upon simplification, the answer is 2 by 7, which is a rational number. Understood? See, 2 by 7 is there. Root 7 will get cancelled. Okay, so only 2 by 7 will remain. So 2 by 7 is a rational number. So the answer is a rational number. Then 1 by root 2. See, I am not doing the rationalization part or something. Rationalization also you can do, or you see, we know this is a division between a rational number 1 and irrational number root 2, and we know that upon dividing a rational and an irrational number, the resultant number is irrational. The resultant number is irrational. See, 1 by root 2 is there. 1 by root 2 is there. So this is the 1 is irrational, root 2 is irrational. So if you divide this, the resultant value will be irrational. Like, see, if you do rationalization also, if I do rationalization also, rationalization, this is 1 by root 2 into root 2 into root 2. So this will become root 2 by 2. Root 2 we know 1.4142 and so on by 2. So this will become 0.70. Okay, 7571, something like this. Understood? No, this is not right. 70 21 something like this. Okay, so this is what? This is a non-terminating, non-recurring decimal expansion. So it is a irrational number. From here also you can do, but if it is root 11, you do not know the value of root 11, so you have to use the property. Fifth number is 2 pi. Same, you have to write the same thing here. Multiplication, same. Multiplication between a rational number 2, this is what? 2 into pi, 2, and an irrational number pi, which gives an irrational number. We know the property. If you multiply a rational and a irrational number, 2 is rational, this is irrational. If you multiply, you are going to get a irrational number. Understood? Now second question is given. Simplify each of the following. See, again the simplify each of the following expressions. Understood? So first question, it is given as 3 plus root 3 into 2 plus root 2. Okay, so first question is 3 plus root 3 into 2 plus root 2. So 3 into 2 plus 3 into root 2. No, see. 3 into root 2 plus, then this is 2 into root 3 plus this is root 3 into root 2. Okay, 3 into 2, this is 3 into root 2, this is 2 into root 3, this is root 3 into root 2. 3 into 2 is 6, you can add this. 3 into root 2 is 3 root 2, 2 into root 3 is 2 root 3. This we know root AB equals to root A into root B. So root AB, so this is root 3 into 2, this is root 6. Okay, so this is the answer. Second question is 3 plus root 3 and 3 minus root 3. Okay, this is A minus B whole square. A plus B into A minus B. This is A square equals to A square minus B square. A is what? 3 square minus B is root 3 square. So this is 9 minus 3 equals to 6. Understood? Then 3 root 5 plus root 2's whole square. Root 5 plus root 2's whole square. Okay. A plus B. This is A plus B whole square. equals to what? A square plus B square plus 2AB. Instead of A, what it is there? Root 5 is square. B is how much? Root 2's whole square plus 2 into root 5 into root 2. Okay, 5 square is 5, root 2 square is 2. This is 2 root 5 into 2. Okay, 5 2 is 7 plus 2 root 5 into 2 is 10. Okay, this is 10. So it is 7 plus 2 root 10. See, I'm writing this, calculating this very fast because see, I've already told you the process. Calculation part you have to be quick. You have to be quick with the calculation. Okay. If you need, you can slow down the video in this portion, in the exercise portion, because I have already done simplification for 5-6 questions in the examples part. Okay. So again and again I'm doing. If I'll take time, so it will be a waste of others' time. If you are having doubt, okay, there is no harm if you slow down the video and watch it. Okay, to make you understand. This is also same thing. Root 2 a minus b. This is a. This is minus. This is b. Okay, this is a. This is plus. This is b. Okay, a plus b, we know it is values a square minus b square. Instead of a, we have root 5 whole square minus b. Instead of b, we have root 2's whole square. This is 5 minus 2 is 3. Okay. Second question is, recall pi is defined as the ratio of the circumference say C of a circle. See, I am going to write the question first, then I will explain to you what it is asking. To its diameter, say D. To its diameter, say D. That is pi equals to C by D. This seems to contradict the fact that pi is irrational. How will you resolve the contradiction? See, in the last class also one question was there. 0.9999, the fraction part, it was coming as 1. In the decimal expression it was 0.9 and it was continuing. And in the fractional form the answer was coming as 1 if we are going to solve it. Why it was like this? Because of approximation. Okay, because of approximation. See, the circumference, see the equation that it has written. See what equation it has written. See, pi equals to C by D, where D is what? This is diameter, this is circumference. So circumference C equals to pi D, or you know this is 2 pi r. You know this relation 2 pi r or pi D. Okay, from where you are getting this relation? See, if you take a circle, wait. If you are going to take a circle, this is the center point. You draw a radius. Okay. You draw a sector actually. You draw what? A sector actually. Okay. You draw a sector. Sometimes it does not work. You draw a sector. This is point O, this is A, this is B. This is sector. This is sector OAB. The sector should look like this, no? The sector should look like this. It should look like this. This should be a curve. Okay. So this should be a curve. But what we are doing is actually we are taking this sector as a triangle. This part we are taking it as a triangle. Okay. And then we are solving this sector. See, this is enlarged portion of a sector. Such sectors, these so tiny sectors, no? we are taking infinite number of such sectors to find the value of this circumference. Find the value of circumference, we are taking infinite such sectors. Okay, this is an enlarged sector. This point A and point B, they are very close to each other. This point A, this is point B, this is point B. They are very close to each other. Okay, since I have enlarged it, it is very distant, but they are very close to each other. This point A and point B. So these are, we are considering, we are approximating that this is not a arc. This is not an arc. This is a straight line. This portion, this is A, this is B. This is not an arc. This is a straight line. We are approximating it. Okay, and upon using, see the limit function, you will see upon using the limit on these sectors, you are finding it. Okay, what you are finding it? Upon using the limit, you are finding the approximate value. C's approximate value is 2 pi r or pi d. This is an approximate value. This is not the real value because you are using limit function. You are considering the sector. You are considering the sector as a triangle instead of a arc. Okay, so you are getting pi d as the answer. Okay, pi d, and pi is 22/7. If you are also writing, now this is not equal to 22/7. This is only approximately equals to 2/7 to ease our calculation. Okay, so pi is a irrational number. Pi is a irrational number. Pi is not a rational number. Okay, because of approximation in calculating the value, we are getting the value means as c by d, in the form of c by d we are getting, and we are telling that it can be a rational number. But no, pi is a irrational number. Because of approximation, it is looking like it is a rational number. Understood? This relation you are getting because of approximation and limit. Okay, and limit. Third question is what? Third question is, we have already done this. Third question is, plot the line root 9.3 on a number line. Okay, plot 9.3 on a number line. So you know the procedure. What is the procedure? First, make a line AB of a length 9.3. Extend it to point C. Okay, point C of length 1. Okay, take a midpoint O. Then draw a semicircle. Then draw a perpendicular. It will meet at point D. Okay, you draw an arc then using BD as radius. Okay, first find the value of BD. Okay, then you draw an arc. It will meet at point P. So this BP is root x. This is BP is root 9.3. This is also root 9.3. This is root 9.3, the value. Okay, so see how we are going to find. See, first we know, using the first step. First step, we are going to draw a line AB. AB's length is 9.3. BC length, then again we extend it, we know it is 1. So total AC equals to 9.3 plus 1 equals to 10.3. Now midpoint is O. So OA equals to OC equals to OD also. Okay, I am writing directly OD equals to 10.3 by 2, that is 5.15. This length is coming as 5.15. Okay, this is 5.15. Okay, radius, since it is the radius. Okay, now OB value you have to find. OB is what? AB minus OA. OB equals to AB minus OA. What is AB? AB is 9.3 minus OA is 5.15. This is coming 4.15. OB is, this is 4.15. So in this triangle, by Pythagoras theorem, we know hypotenuse square. Hypotenuse is what? OD square equals to base square, OB square plus height square, BD square. We want to find the value of BD. So BD square is what? OD square minus OB square. So BD, OD value we already know. This is OD. OD value is 5.15 square because since it is a radius of a circle, 5.15 square. OB value also we know, 4.15 square. See, this is A square minus B square. We know the form. A square minus B square equals to A plus B into A minus B. So we're going to write, instead of A, we have 5.5. 0.15 plus 4.15 into 5.15 minus 4.15. Okay. So BD square equals to, this is 9.3. 5.15 plus 4.1, 9.3 into 5.15 minus this is 1 into 1. So BD square equals to 9.3. So BD equals to root over of 9.3. Now we are drawing an arc with BD as the center, B as the center and BD as the radius. So we are getting BP. BP is also the radius. So BP value is also root over 9.3. See, this whole method I have made you understand in that section. So if you have not understanding it because I am going too fast, you please see that portion first again to make yourself understand what is the total process. Then you come to this question again. Okay. Now fourth question is rationalize the denominator of the following. Okay. First is 1 by root 7. 1 by root 7. This is root 7. Okay. 1 by root 7. We know the process. At the denominator again you have to multiply root 7. At the numerator you have to multiply root 7. So this becomes 7 root 7 by root 7's whole square. So this is root 7 by 7. This is rationalization. Second question, 1 by root 7 minus root 6. Understood? This is what? This is A minus B. This is A minus B. A minus B. Okay. So multiply with A plus B. A plus B. A plus B. Understood? If you are multiplying at the denominator, you have to multiply at the numerator also. So the result is what? The numerator is root 7 plus root 6. 1 into is this. This is A minus B into A plus B. That is A square minus B square. Instead of A, we are having root 7 square. And this is B, instead of B, we are having root 6. So root 6 square. So this is what? 1. And at the top, we have root 7 plus root 6. Understood? Third question is 1 by root 5 plus 1 by root 2. Okay. So this is what? 1 by root 5 plus 1 by root 2. This is A, this is plus, this is B. Okay. If A plus B is there, you have to write A minus B. So this is A minus B. A minus B. Understood? At the denominator you have written A minus B. So at the numerator also you will write A minus B. This is A minus B. So 1 into A minus B is A minus B only. So at the top, A minus B. This is A plus B into A minus B is what? We know it is A square. A square minus B square. Instead of A we have root 5. Instead of B we have root 2. So A square minus B square. So this is as it is. Root 5 minus root 2. And this is 5 minus 2. So this is root 5 minus root 2 by 3. Okay. Root 5 minus root 2 by 3. Fourth question is 1 by root 7 minus 2. Okay, 1 by root 7 minus 2. So this is again 1 by root 7 minus 2. This is what? A, root 2 is B and minus A minus B. If A minus B is, then we have to write A plus B. A plus B. A plus B. Okay. A plus B. If at the bottom you are doing a plus b, at the numerator also you have to do a plus b. 1 into a plus b is a plus b. A plus b. A minus b into a plus b gives a square. A square minus b square. Okay, this is root 7 is 7, root 2 is 4. This is a minus b. Okay, so this is the fourth section that we have covered. So in total we have covered, see, natural numbers, whole numbers, integers, rational numbers, irrational numbers. Okay, and we have covered real numbers, operation on real numbers, and then we have covered also decimal expansion of rational numbers and irrational numbers also. Okay, so we have covered all these. Only the fifth section, that is some powers related to powers of real numbers, then some properties related to it, we are going to cover it in the next section. Okay, so till now if you have any doubt in this video and the previous video, you can watch it, and you can comment on the comment section. I will try to respond to your queries. Okay, any of the queries you have, I will try to respond. And if you dislike some part of this video, like I'm going too fast or too slow, you can tell me about it. I will try to resolve it in the next videos. And if you like also, you can comment about it, and you can like the video, so that I get the motivation to make such videos. Okay, till the next video, stay safe and thank you for watching.